All right, welcome everybody to week 5, day 2. A very common question I get in C++ is how do I make a user interface with like buttons and like images and things like that? Because all this stuff we do in C++ is all like standard in, standard out, reading from the keyboard, writing to the terminal as if it's, 1970s and you're hacking into a mainframe, right? And so the good news is there are libraries. There's nothing in the standard that does user interface stuff. Whether or not that's a good idea is something that people kind of debate. There was a proposal a few years back to incorporate something called Cocoa, I think, into the standard library, and it failed. Maybe for the better, I don't know. But today we're going to be going over one of my favorite ways of doing user interfaces, and it's called Dear ImGui. You can see the spelling up here. And the nice thing about it is that it makes it really easy to get into making a user interface that looks like it's straight out of 1992. And for whatever reason, the font they pick for the default font in Dear ImGui is terrible. It really is. You like it, Megan? Okay. I can't. I just can't. Yeah. Fortunately, the demo code shows you how to change the font out. 'Cause that's like one of the most common complaints they get. But anyhow, it's neat. You can do things like have sliders and checkboxes. And look, the checkboxes do things. When you click on this thing, it does something, right? And all this stuff is actually very easy to code. And this is actually their default example program. And it's almost the documentation for it, too. So they just kind of give you a program, and it kind of has like a little bit of everything in it, right? Where you like click on things and things happen. You click on things, and things happen. You click on these things, they kind of show you how you can do layout, and you can do this and that, and the other thing, no title bar. Look, the title bar vanishes. No move. You can't drag it anymore. Like this one program kind of just shows you, all the options you have for doing a UI in Dear ImGui. And as you'll see in a second, the C++ code to do this is actually really easy and straightforward. It's not probably the highest performance user interface library, but it's easy to write. And that's honestly important because I've been teaching C++ for a long time, technically since 96, maybe. It's the first time I TA'd the class, at least. And it's never been very easy to do, mouse support and like all these new technologies from 1987 and stuff. Like C++ just has never updated. It's standard to even be aware of things like mice and graphics and like the internet and things like that. All of these things are used through what are called third-party libraries. And so if you want to install Dear ImGui, you go to their GitHub page, which is right here. I'll post this onto chat channel. The internet, what's that? Yeah, so like if you want to do internet in a C program, like I guess you can just use the C POSIX libraries, and it's really gnarly. There's better ways of doing networking these days using Boost and things like that. But for a long time, like just doing network, like just basic things in C++ has been kind of annoying. Like basic things like play a sound or connect to a server on the internet or draw a window. Like it's just been needlessly complicated. And the best option for a long time for GUI stuff was called Qt or Qt, not Qt. Just don't autocomplete for me, thank you. And Qt has its own, almost its own version of C++. It uses a lot of macros and reflection kinds of things. So it's got Qt Designer, so you can actually drag and drop objects on the screen. Like it's a very big thing, and it's probably worth learning. Like it probably is. Like it's sort of the standard in C++ to do user interfaces, but I really like Dear ImGui because it's simple. It's really easy to get. Like you just go to the GitHub page here, and you can click on the code and just download a zip file, or you can, if you got GitHub Desktop installed, you can download it any of these ways. Just download the zip, unzip it, and then you're going to see something that looks like this. This is what happens when you unzip it. And you see there's just a couple header files and things like that to install. If you go into the examples directory, I'm using Windows right now. I know. Um, if you go into the examples directory, you can see there is this solutions file here. Double click on that, and that will open up Visual Studio, which will look like this. And on the left-hand side here, you can see all the different source code. Now, what this is, on the left side here, if I like almost minimize these things, it might make it a little more clear what is going on. It actually has an example of Dear ImGui working with a bunch of different backends behind it. And so what's nice is that if you write your code using the Dear ImGui library, you don't have to worry about things like, am I running on a Mac or Windows or Android or whatever. You can have different backends for your Dear ImGui program. These include Vulkan, which is sort of the closer to the metal version of OpenGL. It's not very an accurate statement, but it's made by the same people, Kronos Group. You can have OpenGL 2, OpenGL 3, Vulkan, DirectX 11, 12, 10, 9. And then this one is using the GL for Windows, which is badly named because GL for Windows is available for Linux as well. It's like a helper library to do OpenGL stuff. I like SDL myself. I'm probably going to give you a lecture on how to do the SDL later this semester as well. And so it's all the same code. Like if you were to open up, let's see, let's pick one at random here. Main.cpp here. If you look at it, it's basically going to be the exact same program in each one. I don't know if I can find the same part of the code, but it's basically the exact same program, just with a different backend on each one. The only thing different is going to be these commands here. So prior to the main loop, the setup is going to be a little bit different. And so if you go over here to a different one, this is SDL OpenGL 3. This is GL for Windows OpenGL 3, which again is not GL for Windows anymore anyway. So if you scroll up here, you can see that these are a little bit different. This is an SDL call to, and then this one is implement GL. So they're slightly different up here. This is like the setup kinds of things. GL for Windows pointer, Windows, GLFW create window. Up here, we will have an SDL call instead. Somewhere, where is it? There, SDL create window. So it's an SDL window pointer instead of a GL for Windows pointer. GL for Windows window pointer. And again, it doesn't stand for GL for Windows anymore. But that's kind of what the original abbreviation meant. So the setup is going to be a little bit different between all these different solutions over here. But when you run it, like, I don't know, let's pick DirectX 11, and you run it, you're going to see the program looks exactly like the other one, because it's the same program, right? If you click on these things, no title bar, the title bar vanishes. That's the whole point, is that you no longer need to, no title bar vanishes, right? So this one is the OpenGL one, the other one is the DirectX. You can't tell the difference. And so whatever you have installed on your system, just compile it using that one. Excuse me. And just don't worry too much about the differences. So after you download it, just like click on one of these and then just hit run and it'll build if it's not built yet. And then look, here is the DirectX 11, new options, no title bar. Look, it works. So out of the box, I think I don't have Vulkan headers installed on my system. So if I try running this one, it'll fail. And so if you see a failure, just try one of the other backends. You guys understand? So it ships with like 3, 6, 9, 10, 11 different backend options. Just pick the one that works for you. Okay? You guys understand? Yeah? Okay. So, pretty easy to get into. I've been using SDL OpenGL 3. Again, just hit run, and there you go. So, let's look at the actual demo source code because, like I said, this is an example project that is deliberately designed to sort of teach you about all the different options there are inside of Dear ImGui. Okay, and I'll kind of go over the Dear ImGui philosophy, I guess you might say. Writing code in Dear ImGui, making buttons and things like that in Dear ImGui is very different from Qt, for example. It's a completely different paradigm. Okay, so we're at the top of the file here. It's got some documentation. It's got a link to the documentation here. The documentation's pretty good for it. it has like, hey, you want to make a slider float? Boom, here's the source code for it. You want to do this thing here? Here's how you do it. And so there's the point is actually not for the documentation to show you how to do this stuff, but for the demo code here to show you. Okay. And so all this stuff is set up. So maybe scroll out a little bit so you can kind of see maybe a little bit from a high level, zooming out, what's going on here. Here's main. When it runs, all of this is just setup code. You don't need to worry about any of that. Just leave it alone. Scroll past, scroll past, scroll past. If there's something you want to turn on, like gamepad controls, they have the code in there. And so if you want to enable gamepad support, uncomment that, you got gamepad support. Congratulations, right? Do you want to turn on docking or turn off docking? Docking means you can snap the little sub windows around and things like that. Turn those on, turn those off. Do you want to use dark mode, classic mode? So if we just switch those out there, hit save and run. The colors change, right? Okay. All right, so turn on rounding of windows. It's all these things, like there's little comments that they just say, just tweak this value here, and then it'll look different. Here's instructions on how to install a new font and how to set the default font in your ImGui so that it doesn't look like garbage. Circular window, especially for that one Windows phone that flopped. My friend Scott is shedding a tear out in Mountain View right now. He worked on the Microsoft Kins. Okay, so we've got here a couple, what you might call, let me zoom back in, read this. Okay, so everything above the main loop is just setup. Okay, now these things, you can think of these things almost as like globals. They're not globals, they're part of main. But you think of them as globals for your dear ImGui program. So if this variable ever returns true, the demo window will be shown. If it ever turns false, it will hide the demo window. So if I switch this to false and run it again, you'll see that window that was over here is gone on the right-hand side, right? But if I click on demo window, boom, it appears. Okay. So that's like the initial state for the demo window. And you can set colors and things like that. So it has its own, this is like a vector, but it's not a vector in the sense of like a C++ vector. It's a sense of a vector like in game engines or physics or something like that. So a vector just means more than one number, right? And so this is a vector 4, it just holds 4 numbers, and it's holding 4 floats in this case, which corresponds to R, G, B, and A. A is alpha. A 1 means it is opaque, which is pretty normal. Main loop. Okay, so here we go. So this thing here says while, and it's got this long thing here. Basically, if we ever click on the close, am I in the GL for Windows? I am, aren't I? Let's get out of that one. Do this one instead. Okay. While not done. This one's a lot easier to understand. Okay. So we have a variable called done. If that's ever set to true, the program quits. Okay. And it's a little bit easier than that function call, which is like, did they click the close button, close X, top right. Okay, so SDL is we're gonna have a probably lecture on this in a couple weeks, maybe next week, who knows. I move as the spirit moves me. So the SDL is the underlying level beneath dear ImGui, and it has a event system where every time you click or hit a key or something like that, it adds an event to the event queue. And then this thing here is saying, while there's still events to be processed, process the event. And you don't have to really mess with this. They've already written a function to process all of the events that come out of the SDL. Neat. If any of the events was quit, then it sets done to be true. So if you ever click on the X, it'll set this variable to be true. Next time we go through the while loop, done becomes true, it quits the program. Okay. And then if you get a window event and you get window event close by hitting that, same thing. Okay. So that's how we handle closing the program overall. Here we are creating a new frame, OpenGL3 backend, yes, okay, and then SDL2 sitting on top of OpenGL3. So you have OpenGL3 as the bottom layer, then you have SDL on top of that, then you have ImGui on top of that. And if you're like, well, why don't I just write it using OpenGL calls directly? There's a reason why there are helper libraries to make OpenGL easier. It's because when I was a junior in college, I took an OpenGL class, and we learned all the functions and how to do stuff, and even then, like, we used helper libraries to do things like create windows and things like that because it's a pain. And so there's a phrase in computer science that any problem can be solved with one more layer of abstraction. So you zoom out, and so you have the lowest level calls, and then you have a library that helps you make those calls. Like, just make me a window, I don't care, and then you have a library that sits on top of that, and then you have a library that sits on top of that, and at a certain point you have to do something. But here you end up with something that's pretty abstraction hell. It can be. But here you can see it ends up with something that's not too bad. Like, it's just, this thing's going to handle it for us. It's going to handle all the events for us. Cool. All right. So this is if show demo window is true. That's the window on the right-hand side. Then it calls the function show demo window. And that's actually a function inside of ImGui. So ImGui has a function to turn that demo window on. And that seems weird, right? Like, why do you have a function call to pop up that thing on the right-hand side? Like, that's weird, it's like the standard library having a function in it that just calls each one of the CMAF functions once or something like that. That seems really heavyweight for a library. But the reason why it's there is because this function here is actually really good at testing to see if your ImGui installation works, right? Am I drawing things to the screen? And sometimes, like, when you're starting from scratch, you have a blank screen, you need to just put stuff on the screen and see if it works. And so the show demo window, you just go bloop, and then it goes bloop, and you're like, all right, it's like the hello world almost, right? Like, just let me see if mouse clicks are working and all this kind of stuff is working. And so with one function call, you can see if everything's refreshing properly and stuff like that. Okay. So the demo code here is actually the left side. So if we run this again, what we're messing with right now is this part, okay? And so you see where it says hello world, and this is some useful text. So the big demo window, in fact, I'm just going to hide that right now by default because I don't want it distracting us. So click on that. And over here, you can see this is what we're working on here. So how do we make this? How do we make this in C++? How do we make a little floaty window thingy, right? How do we do this? And how do we make buttons and things like that? So as it turns out, in ImGui, it's really easy. Now note this scope here isn't connected to anything. You guys see that? It looks like maybe it should be attached to that if statement up here. It's not. This is something called an anonymous scope. And so inside of C++, just whenever you want, you guys know this, you just be like, int x. That's perfectly valid C++. Bruce, did you know that? You can do that. You can do that. Yeah. You can just write it. You just make a scope. And the reason for that is because that makes this variable go away, right? So normally if you make a variable, that variable is with you for the rest of the function. But if you got a really big function, then you're stuck with it, right? So I wouldn't do it for integer x, but if you have like a vector of integers and vec of size, whatever, like you might want it to go away. You know what I mean? Like, you might want it to be deallocated because you've just allocated a lot of RAM, and if you're within main, it'll never get deallocated, right? So if you need to like free it up, if you put it within a scope like this, it will get the destructor will be called here. You guys get that? So Megan, I understand you hate it, but like, I think you can see, and I don't do this very often. It's not, particularly something that I recommend, but it's a way that you can kind of control when things exist. Yep. So this here is an anonymous scope, and learn something new every day. Yeah, and in CSI 26 today, we learned about lambdas and ternary operator and pragma once, and yeah. So you never stop learning computer science. Part of the fun. Part of the fun. There's always more stuff to learn. So here we are making a variable named f, and it's static scoped. So static scoped means it's a global. So it is as if we had put this variable here in the global space, but it's only available within this scope here. So other people, if they have an f, like it doesn't touch this guy. But it's as if we scroll all the way up outside of main, all the way up outside of main, we had said like float f here. It's a global that's not global. Does that make sense? Do you understand what we would do that for? Globals preserve state, right? Like this value here doesn't get reinitialized. It looks like it's going to get set to 0 every time, but it actually preserves the number from the last loop. So basically we can record things like our frame rate, or here we can count how many frames we've done total. And this is not getting reset to 0 every time we run through the main loop. It's static. It's a global. You can think of this counter as being out in global space, and every time we add to it, it's permanently increasing by 1. And the neat thing is we can only access it here. So other people can have a variable called counter, and it's not going to mess with our global. This global is only accessible locally. So this is kind of a neat thing also. Okay, now let's get into the dear ImGui stuff. ImGui, : begin, hello world. Okay. So this will be matched with an end. So every begin has an end, and everything between the begin and the end is in that little floating window. Okay. Wait till you start learning async. Yeah, you don't need async for this though. And so with a lot of UE stuff, like you set callbacks and things like that, and they sort of asynchronously get clicks and execute code. With your ImGui, you actually don't need any of that stuff. It's actually very nice, very simple. So ImGui : text. This is some useful text. So what does this do? It's one line of code. It's one line of code, and what it does is, let me run the thing again. This is some useful text. Look at that. So we made a window called hello world. The ImGui : begin makes this little floating window called hello world. And then the first line of code, here's some useful text, right? And then the next line is demo window. So you just are literally just writing lines of code, and the lines of code that you write just appear boom, 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 boom inside of your user interface. And this checkbox here, checkboxes can either be true or false, right? You check them or you uncheck them. And by passing in this variable here by reference, what's happening is when you click on it, it changes this variable. So if you check the box, show demo window gets set to be true. If you uncheck the box, show demo window gets set to be false. If you remember, set demo window is our global up here. And every refresh of the screen, we check to see if show demo window is true. If show demo window is true, we show the demo window. And it's passing in this function, this variable by reference as well, because it can close itself out. You can click on the little checkbox, and then it will close the demo window and set that to false for next time. Can you manually adjust for things show? Yep. But by default, it just lays out, top to bottom. No, nothing more complicated than that. This is literally the easiest user interface code you're going to see in your life, and you can work as a UE person as your career. One of my friends that I play Valheim with, she is a UE person, and that's her career. She does this kind of stuff for a living. One of my former students, who is now back at Clovis Community College, she graduated from UC Irvine, worked in UE, says the field has too many people in it right now, and so she's going back to school for nursing. So maybe it's not the best option. Maybe you should do machine learning and AI. That's data science. Those are sort of the hotness right now. Games are popular as well. So First time I ever touched CSS, I made the entire website very slowly tilt a few degrees. All right, calm down, Satan, my lord. Okay. So checkboxes can be checked or unchecked, and then that's all it takes. You don't have to write a callback to say when they click on the checkbox box, get the value of the boolean and invert it and then save it, which is what you normally have to do in UE code. You have to have a callback and a function that gets called when. Nope, this is dear ImGui. It's as simple as that. It just writes the value. It'll read the value of the variable, and that determines whether it's checked or unchecked. Right? So if this value is true currently, it'll be checked. Right? And it's refreshing over and over again. So you can see here, I'm getting 144 frames a second. Right? And so it's refreshing the screen 144 times a second. If I click it, it not only reads the value of the checkbox, but it sets the value of the checkbox. And then the next time the program refreshes, the demo window hides. Simple as that. So every time you refresh, it's like it clears the entire screen. You just redraw the entire screen over and over again. That's why it is not high performance, because we are rerunning the UE 144 times a second. Whereas in a retained mode user interface, it just stays there until something changes, which is much more efficient. It's more work to program, though. So it's not that bad. You made far worse than a tilting, leaning tower of pizza. I almost said pizza. I don't know. It's pretty bad. Okay, so slider float. So this thing here is going to make the right here, and so that just gives you a number from 0 to 1, and the range is from 0 to 1, as you can see right there in the code. And at any point, you can just get the value of f. So it's passing an f by reference here. And below this, I could just like use the value of f, like somewhere, like here. Instead of the counter, I just put an f and run it. And now you can see. Oh, that's that's an integer. It's parsing a float as an integer. That's fun. You can see here that this label here is getting the. Yeah, that's a mistake. Let's change this. Well, there we go. So you can see it's getting the value of f right here. Makes sense. And so the slider float here creates a user element that you can click and drag on. It sets the range, minimum and maximum, and it's reading the value of f, and it's writing the value of f. When you drag on it, it just sets it. And then later on, you can just use that value of f in your code however you want. It's just set. And so if you have a video game, you can pop open a Dear ImGui window, be like, type in your name, type in your stats, whatever. And these elements of the user interface just set the variables themselves. It's easy as that. It's really nice. What's the full potential of the GUI? Like everything you see on here on the screen, like the run, like all this stuff is GUI stuff, right? Like it's literally, how normal people interact with programs. On a phone, you use a touch interface. On a PC, you use a mouse interface for things and click on things. And then when you click on things, things happen. And that's, Dear ImGui makes that ridiculously easy. So I'm a big fan of it. I've been searching for a long time for a UE library that is easy enough to teach my students. And so I think I'm going to be actually teaching all of my third semester students Dear ImGui this semester also. You guys get to be the guinea pigs. We'll see how you do at it. Okay. For normies, yeah. So unlimited potential is correct. Unlimited potential is the right answer. Yeah. So but normal people don't like they look at what we do as like terrifying, right? Like they're like, oh my gosh, it's so scary. Like they don't like operating in the text world. So they like clicking on things And to be fair, like to be fair, it is easier to work with, buttons and things like that. It's less efficient, but it's easier. So, I hate web dev because I don't have the attention span for it. I'm awful at aesthetics. I feel you. I want to learn, but I can only pay attention for like 5 minutes. It's not fun. Yeah, I actually did journalism for 3 years, and so we learned how to do like layout, like making an appealing, aesthetically appealing layout, and have text flow and things like that. So yeah, and then if you do web dev, you have to do JavaScript, which is just an inferior programming language, right? Like it's I don't think that's particularly controversial. Like you can use TypeScript for sure, for sure. But JavaScript is just such a mess of a language. Like if you just understand JavaScript is just something a guy made over a weekend, like it makes a lot more sense. You know what I mean? Kind of like makefiles. People look at makefiles like, why is the syntax for makefiles so weird? And the answer is because the guy didn't expect it to be the final product. He made the makefile format and then he left on vacation. And then when he came back, everyone was using it. It was too late to change them. So, JavaScript, I think, was made by, if I'm remembering it right, it was Mozilla, Brandon Ike, yeah, which is now Netscape, which is now Mozilla, kind of. Creation. Choice of JavaScript caused confusion because it made it seem like it was related to Java. It was a marketing ploy. Yeah. Whatever it was, like it was just sort of like this hacked together thing that is now the web standard for web coding, and it's terrible. I used to love it, but it's just bad. It's slow, untyped, no pointers, no semicolons. You can put a semicolon if you want, but if you don't put one, it puts one in for you. if it will result in usable code, JavaScript will just add a semicolon for you. So yeah, it's yeah. I've done JavaScript programming. I prefer not to. Let's put it that way. Okay, so if you want to make a color edit 3, color edit's like a color picker. Like this, clear color. Got a little color picker here. It's pretty. It's a nice color. Nice shade. You do that, and you can see the RGB values here. 185371. I like that. It's a nice shade. I'm gonna write that down. Might use that for something. I don't know. So that's 185371. Might use that for something. That's a pleasant shade. So you can see as you adjust the thing, the background color changes, right? These labels change here as well. So clear color was that vector 4 right here, right? And so as you do the color picker, it's writing into this vector here. Again, a vector is just 4 integers, or 4 floats, sorry. This is not like the C++ vector, which is a array that grows over time. Maybe potentially you can push back into it. No, this doesn't grow. This is just 4 numbers. Okay, so the clear color is probably set somewhere. It's a background color. Anyway, so that's how you do color pickers, and then here you can make a button, and that's kind of the most important thing when we're talking about UIs is make a button, right? Because that's what everyone wants, right? You want to, you're playing a video game, and it's like, hey, what's your name? And a little form pops up, and it's got a text entry, and then there's a button that hits submit or something like that. That's what everybody wants. Check this out. Look at this weird thing here. It's an if statement. It's an if statement. That's how you make a button. What? Yeah. So this is a very interesting design decision from the ImGui people. Basically, that if you don't have the if statement there, if you just come on, wake up. All right, whatever. If you don't have the if statement there, it'll put the button there, but it doesn't do anything if you click on it. So what happens is if the user clicks on the button, it returns true. And so whatever follows the if statement, in this case counter plus plus, am I frozen? Okay, there we go. Executes when they click the button. And so that's it. You don't have to have a callback. You don't have to have a function pointer that you pass to the code that when they click it, it asynchronously calls back your function. Nope. Just every time you click the button, the counter gets incremented once. And if you want more complicated stuff, you can, of course, I'm not in Vim mode. Sorry. You can, of course, put curly braces there and do more stuff inside of there. So you make it play a sound or whatever every time it clicks. So that's it. That's all it takes to do a callback on a button, which is you just say if the button, and then every time the button gets clicked, the if statement, the body of that if statement, the code block attached to the if statement runs every time they click. Simple as that. And so, that might make your program a little hard to read if you're putting, if you've got 100 lines of code here inside of the code block. So you probably want to put it into a function, at some point, to keep your user interface and your stuff that happens when you click on the user interface separated a little bit. But for something simple, you can just do a little line of code like that. Boom, done. Or you can call a function and have it, start a new game, load a level, whatever it is you're trying to do. ImGui, same line, counter equals, and then I changed that. That's going to be different on yours. So by default, every time you do a new line in ImGui, it goes to the next line. That's the default layout. A lot of programming languages, when they do UEs, they give you a lot of control over your layout, and ImGui actually does too. But the default layout in ImGui is actually sane. It actually works pretty well. You just line, boom, boom, boom. We got a slider, next line, color picker, next line, button. And if you want something on the same line, you do ImGui, same line. And then, boom, simple as that. It appears to the right. I worked a lot with UE layouts in Java, using both AWT and Swing. And it gets so complicated. It is just ridiculous to get it to work right, especially when you're doing things like resizing. Look at this. See how these things resize, very common in Java when you do this for things to just start, just exploding all over the place. You have spring-loaded things and box layouts and all this kind of stuff. The default layout in ImGui is just top to bottom, and if you want things to appear on the right, you do that. Done. Text. This thing here is a format string. Resizing windows is the bane of all web devs. Yeah, it's really, yeah. A lot of times websites will sort of make assumptions about how big your screen is, and then if you are smaller than it, how it reacts to it is variable. And then you go on mobile, and then everything changes as well. Yeah, doing layout and having your thing react to different sizes is Megan says easy, but I don't know. I've had my layouts explode. More tedious than hard. Okay, fair enough. So yeah. So this thing here is called a format specifier. This actually comes from C. So when you do printfs in C, there is what's called a format string, format specifier, and this is for float. I think does G work also? I don't remember all of them off the top of my head. Yeah, G works also. D is a decimal, in other words, an integer. That's why I was getting that weird thing, because format specifiers don't type check properly. This is one of the reasons why Bjarne came up with cin and cout instead of printf and scanf, because cin and cout know what type they're couting, and they can format it properly. When I had this error in here where I have a float here and an integer being printed, it's going to interpret the floating point IEEE format as an integer, which is just completely wrong, as you can see here. So, and there's no warning on this. If you're doing a printf, it would probably warn because it's such a common mistake. But yeah, it's not type safe. That's one of the reasons why we use C++, CINs and Couts. But they're doing the label on this using the format specifier. So you can actually write variables into the string very simply and easily like that. A lot of people like format specifiers. I don't mind them. They're actually more compact than CIN and Cout. Like, if you're going to cout a bunch of variables, you have to do like cout A, B, C. You know, it's like, oh my gosh, you know, it gets really gnarly. In C, this would be printf decimal space decimal space decimal space decimal backslash n. See, that's like half the length. And you can actually see kind of the format at a glance, right? And then, oh yeah, then you'd actually put A, B, C, D in here. Sorry. Like that. And then wherever you have a format specifier, it grabs the variable and puts the value of the variable in there. And so you can actually see what the format's going to be kind of from a distance, you know, and then the variables like swap their values of the variables in later. This is called like chevron hell in C++, where you just have these double left arrows all over the place, and it gets really big and expansive. So C++ has added FMT, libfmt, or format. They actually have print now. And this is actually a new thing in C++. Kind of kicking it back old school, but it's type safe. So they now have a type safe version of printf. Finally, in C++ 23. Is it out yet? No, at least not on my server. It's still not part of the standard library. It's in the standard, but the compiler people haven't caught up. The standard library author people haven't caught up to it yet. Std format, yeah. If you want it, right now, there's something called lib format, which is actually a little bit more powerful than the one that made it into the standard. So you do things like this. And you could, of course, use namespace FMT, and then you just call print. And it just does it's like a cout. And then you can do things like this. This is why it's type safe. You put the curly boys in there, and then it substitutes the value of the variable into that. And so it knows what the type is. And if you want things to go in a different order, I don't know why you would do this, honestly. This is parameter 1. This is parameter 0. So parameter 0 is right. It is better. I'd rather be happy than right. That's what that's going to turn into. Mostly, though, you just do it like this, where you're like, put in a variable, and then these things will just appear here. And so that's like the C++ version of printf. So you don't really need to know format specifiers, except format specifiers show up in a lot of places. There's a lot of places where you're still going to see format specifiers like this. Dive into systems has a good dive into systems, free online version, collection of documents. Let's see here. Search printf. So yeah, dive into systems has a section on format specifiers and how they work. And so you can do things like specify how many digits you want, five decimals before, 3 decimals after, 20 character wide strings. And so there's a lot of detail that goes into these format specifiers. I will post this onto chat as well. So print call for multiple variations. I could see that. Yeah. I could see, like, if you want the same variable to appear multiple times in an output string. I could see that. Yeah. It's cool. For example, you have an image gallery on a full-size computer that has 3 pictures across. And then you can write things like the screen's small, make it 1 picture across. Yeah, that's cool. Nice. So they have a flexible column in Bootstrap. Nice. Okay, cool. So what is your assignment? You are to... You're going to make a Office program in ImGui. So write Doom? Nope. you are going to. Oh, that's Seaside 26. Sorry. You are going to use your ImGui. You're going to learn the interface, and you're going to make a little office app. It doesn't have to be like anything major. Don't stress out over this. It's not supposed to be stressful. I just want you to show me that you know Dear ImGui. Okay. And demo code, make a boring office app. Be creative, do stuff, but also don't kill yourself. It's not supposed to be hard. Okay. And then screenshot it, post it on Discord and onto Canvas as well. So that'll be due on. I'll give you guys a week on that one. So download it. I use Visual Studio for it. And you can see here, that's it. Like, text, and then it ends. And so just make a little thing where people can do things, nothing crazy. Just make it, look like a boring office app, something that, you're going to be forced to use when you enter the real world. Megan, should you make another one? Yeah, or you can work on the one you have, maybe add a little bit to it so that you're not bored for the next week. I don't want you to be bored. Just add a little bit to it, maybe a couple more buttons, a couple more options, and things like that. Nothing. Again, I don't want you killing yourself. It's just put a little bit of effort into it. Learn some new things. All right, so that's it for 50B today, guys. Thanks for coming out, and I will see you guys on Tuesday. Peace.